Have you ever wondered how you would react to a fire in your facility? Do you realize how much time you would have to get out alive? Do you know what actions you would take to save yourself or someone else? Do you know how to operate a fire extinguisher? Do you know the answers to any of these questions? You should. Hi there, my name is Jeff Johnson. I'm a Deputy Chief and a Wisconsin State Fire and Service Instructor, and I'd like to teach you about fire safety. In my 25 years of fire service experience, it has taught me to always be prepared for a fire, because in a moment's notice, any time or any place, a fire could happen. Wouldn't you like to be prepared too? What I'd like you to do is stop the tape and take the pre-test that has been provided to you in your materials. Don't worry, the test won't be graded, and we'll review your answers at the end of this tape. When you have completed the pre-test, there's an excellent video that I'd like you to watch called Firepower from the National Fire Protection Association. The video may be obtained through your VTAE district or your local fire department. Now let's get started with the program. Welcome back. I'd like to take a moment to talk about the workbook. The workbook will have a number of units in it which we will go through. Some of the corresponding units will have handouts that we would like you to review. If at any point in time you have any questions, because this is video based, we'd like you to stop the tape, write down the questions, and address those to the facility owner. The purpose of this training is to, first of all, reduce your anxiety about fire safety. It's also to develop an awareness of fire safety and the fire safety problem. It's to understand fire and its properties. We would also like to teach you to react instinctively to a fire situation if you should have one. Understand resident abilities and limitations in their self-preservation. And we would like you to learn how to prevent fires. Some of the desired outcomes in the course we want you to understand fire development. We want you to understand fire prevention, classes of fire, fire extinguisher use, fire alarm systems, sprinkler systems, awareness of the potential in CBRFs. We want you to know instinctive actions to take if you have a fire. We also want you to be aware of emergency planning that must take place in your facility. We need you to be able to assess the facility and the residents properly for fire safety problems. We want you to use good fire prevention techniques, and we want you to be safe in fire safety in your facility. Some of the attitudes that we hope that you get from this course is we want an increased awareness about the fire safety problem, not just in facilities, but in your home as well. We want you to become alert to fire hazards that you may have. We also want you to be effective in fire drills in your home and evacuations. We want an objective with fire safety as your residents, and we want you to be proactive in fire safety education for yourself and the people that you are caring for. We want you to set a good example for those living, working, and visiting in your facility. We would hope that at the end of this course that you would get something that you would be able to take back to your facility and above all be fire safe. I'd like to take a moment to talk about fire behavior. Statistics show that most Americans will encounter a fire within their lifetime. Although Americans are generally concerned with product safety and consumer safety, very rarely do they think about safety or burn education. Everyone really needs to be concerned about fire, because fire can happen at any time and you need to be ready for that fire. You should learn about burn safety. Your life may truly depend on that. If we look at the definition of fire, it's nothing more than a rapid chemical reaction that gives off energy in the products of combustion with very different composition in the form of heat and light. Fire needs really three things to burn. It needs oxygen, it needs heat, and it needs a fuel. In the fire service, we call that a fire triangle because it has three sides. Each of those sides represents one of those elements. The first side I'd like to talk about is the oxygen side. First of all, when we're standing, we're breathing normal air, is at about 21% oxygen. A fire burns relatively well in that enriched atmosphere. As we breathe or as the fire burns, it will tend to burn up the oxygen in the area. Fire is typically in a space or a confined area, will consume that oxygen as they burn, and eventually they will go out. If I take a pan and I place it on top of that space, illustrating the fire as actually using up the oxygen in that space, eventually that flame will go out. When we have a fire, we try to look for ways to smother the fire if we can. There are some types of fuels that will create their own oxygen while they burn. Although it is relatively rare that you'll find that in your facility, they are out there. Some of those examples would be bromines or chlorates or fluorine, iodines or nitrates. The oxygen side of the triangle is the side that we like to take a look at to smothering if we're going to put the fire out. The next side of the fire triangle that we would like to talk about is the heat side. There are a number of different ways that heat could be in your facility. Fire needs an ignition source to start. Ignition sources could be a number of different things. They could be a stove, an element on a stove. They could be an open flame on a gas burning stove. They could come from sparks. They could come from arcing equipment, grinding or electrical, or they could come from lightning in a natural source. They also friction could be created by rubbing two surfaces, would be an ignition source. And also a chemical reaction could occur between substances that you mix in your facility. It also could come from spontaneous combustion. If you have oily rags or wet charcoal in your facility, that could create enough heat to start a fire. The heat side of the fire triangle is a little bit more difficult to remove in that we have to actually cool the fire to a point to put it out. In the fire department, we carry a lot of water that will cool a fire relatively easily. However, in your facility, the amount of water that you would have might be considerably reduced. Some of the larger facilities would have sprinkler systems which would then control those that heat side and cool the fire to put the fire out. The next side we're going to talk about is the fuel side. The fuel side is rather in depth because there are a lot of different fuels that we need to discuss. The first thing we'd like to talk about is solids. Now solids, as we look at a number of things in the facility, solids would be all the ordinary combustible type things, wood, paper products, plastic, or rubber. Your furniture, the types of things on your furniture, draperies, wall coverings, all of those things are considered solid objects. There's different sizes and shapes to solid fuels, and that would significantly affect their ignition. What we talk about is a surface to mass ratio. When we talk about surface to mass ratio, there's a concept and an example that I'd like to take you through. First of all, if you think about a board, this is a solid object. Really, relatively surface-wise, it has a very small amount of surface ratio to its mass. It's got a large mass, but a small surface. If we take that wood and we put it into a piece of paper, our paper now has been reduced in mass, but it has a very large surface area to it. If we take that piece of paper and we turn that into wood shavings, the wood shavings have a tremendous amount of surface area, and they're very small in terms of mass. If we would try to light each one of these, we would find that the more surface area we have to the mass that we have, the more surface area would light relatively easily, whereas the large surface and the more mass would light very difficultly. What you need to do is take a look at your facility and identify those different areas. For instance, if you have a lot of newspaper stored, that's going to be easier ignitable than your furniture. So take a look at the heat sources in relationship to the fuels that you have, and then identify those and try to be prepared for any types of fires that you would have in regards to the surface areas of fuels. With a solid fuel, not only is the surface to mass ratio important, but it's also the way that the fuel is presented to the ignition source. If I take a piece of paper and I turn the paper sideways and hold it horizontally, and I touch that to a flame, the flame will burn gradually across the paper as it spreads to the other side. If I take that same piece of paper, but I hold it directly over top of a flame, that flame will burn much faster throughout the paper, simply because there is more surface area, and the way the paper is presented presents more area to burn to the flame. So it depends on how the fuel is presented to the flame with regard to how it's going to burn. When you take a look at a fuel, you need to look at those types of things in preparing yourself. The second thing we would like to look at with fuels is liquids. Liquids are a little bit more difficult to control because the number of extinguishing agents that you may have may be limited in terms of the amount of liquid that you may carry. Liquids are categorized as combustible, or they're categorized as flammable. Both will burn given the enough heat, or the right amount of heat that would be exposed. In order for many fuels to become flammable, they need to be heated, and they need to give off a vapor. Some liquids will give off a vapor in normal temperatures. Other liquids may have to be heated. One thing to remember about liquids is that the surface area of the liquid is dependent upon the container that it's in. A small container would produce a small fire. A large container would produce a relatively larger fire. If I take an example where this glass of water would be a flammable liquid, the surface area of liquid that I have in this particular case is just a couple inches in circumference. This particular, if I started this on fire, would produce a relatively small fire. However, if I took the same liquid that is in this glass and I poured it into a pan, the surface area now is increased based on the pan's surface itself. So the same amount of liquid dumped onto a floor perhaps would burn a larger area. It's important to note that in any situation where you have flammable liquids, it's not only important to keep them away from heat, but it's also important to keep them in a closed container so that you do not dump them out and create a larger fire. The last state of fuel that we want to talk about is the gas or vapor state. Typically, you may find these types of fuels as natural gas to burn in your furnace, or to heat your stove perhaps. You might find butane, or you might find methane in your facility. Gases are produced from both liquids and also from solid fuels, and quite frankly, all of your fuels, no matter what the state, needs to be in a vapor state in order for that to burn. That's why gases are so volatile, because most gases are already in a state ready to burn with an ignition source. Gases are the most dangerous fuels in terms of ignition because they can produce the most violent reactions with fires. You do not want to accumulate large amounts of gas in any confined area. With the right amount of gas and air, given an ignition source, an explosion could occur. CBRF's primary concern would be to stop any gas leak that they might have. A gas leak might be produced from a stove, might be produced from a meter outside. And in any situation where there's a gas leak, it's going to be difficult for the facility to stop that flow of gas. If you cannot stop the flow of the gas, an obvious evacuation would have to be complete. It's important also to note that natural gas is not a toxic substance. It's more of an asphyxiant in a way that it replaces the oxygen in the air, and you would suffocate rather than have any toxic type issues. The last thing that I wanted to talk about is chemical chain reaction. If we were to take our fire triangle and put a fourth side on that, it would become a pyramid. Not to confuse you with the other three sides, they're both important, but If you take a burning process, that burning process needs to have fuel, it needs to have oxygen, and of course it has its heat source because it is in fact burning. As that burns, it creates other elements. Solid fuels give off various gases of different types, and those gases are then mixed with other oxygen, and with the ignition of burning, it will burn. This is called a chemical chain reaction. The chemical process of fire itself produces the chemical chain reaction of fire. An excellent example of a chemical reaction is a forest fire. Taking a look at the forest, one tree would start on fire, that tree would then spread to other trees, and a reaction would occur. As long as there is the heat of the fire, as long as there is oxygen, and enough trees in the forest, which usually there are, that reaction would continue to burn until an intervention, such as a fire department or a wildland fire team, would put the fire out. The reason why I tell you this is because with fire, until the intervention is there, fire will generally continue to burn. If it starts in a room, it'll spread to other rooms. If it starts in a home, it could spread to other homes. Somewhere the intervention needs to take place. And what's important is the facility person, the caregiver, needs to take a look at that and identify what point or what intervention they are going to perform. Those are points that we're going to bring out later on in the units. The next point we're going to talk about is the stages of fire. Fire burns and fire grows, and as it grows, there are different stages associated with that growth. When the three elements of the fire triangle come together, that fire will ignite. As long as there is oxygen, fuel, and heat, the fire will continue to grow. There are three stages, the first stage being the beginning or incipient stage, the second stage being the free burning or growth stage, and the third stage is the smoldering or decay stage of the burning process. The first stage, the beginning or incipient stage, is a relatively small fire, understanding it's the first start or ignition source of the fire. Sometimes we can find that happening in front of us. Other times we may be awake or in another part of the facility. It's usually the first flame. Sometimes the first flame may smolder for a while, but eventually with enough fuel sources and oxygen, it will begin to grow. Temperatures usually in the area are at 100 degrees or slightly over. The oxygen area in the room would be nearly normal, and smoke and fire gases would start to collect at the ceiling levels. You can imagine as a fire grows, it would produce the smoke that would again develop in that area. And depending upon the size of the area, it would dictate the amount of smoke and how fast it would grow. You would also have what we call thermal updraft. If you take a look at a chimney, as a log burns in a fireplace, that thermal updraft goes up through your chimney and vents outside. If you take away that chimney to the outside, the thermal updraft would grow and then collect at the ceiling levels. During this stage, a fire may be extinguished with a fire extinguisher if you are trained in use with that extinguisher. Because this program does not give you first-hand experience with an extinguisher, it's important that you try and get that experience. You would be better qualified to put out a fire. But the incipient stage is a very small stage, the first beginning stage, and that is where an extinguisher would be very helpful if you had one available to you. The next stage that we'd like to talk about is the free burning or growth stage. If there is no intervention in the incipient stage, the fire will continue to grow and develop as it burns up other fuels in the area. Depending upon the amount of fuel that you have and the oxygen supply that you have, a fire can become very, very large. In fact, in many cases, if the fire department is delayed in arriving, we would not have the resources to control a fire to a particular room. We may have to control it to a particular building itself. With more fire, it takes more resources and more water to put the fire out. During the free burning stage, temperatures with this growth can be considerably greater than in the incipient stage. As the incipient stage grows, you can get temperatures in excess of 1,500 degrees. The highest point of the free burning phase, you may have temperatures in excess of 1,000 to 1,500 degrees at the ceiling level. Certainly in the free burning stage, you're going to have very limited time or no time to get out of a particular building. As the temperatures increase, they start to decay all of the materials that are burning within the area. As those materials are burning, or as those materials are heated, they are giving off various vapors, and that is also collecting with the other elements of the fire itself. There's a certain term in the fire service known as flashover. Flashover is really when all of those elements come together. The heat from the burning process in the room, the vapors that are collected at the ceiling, and enough oxygen, everything will ignite simultaneously. This is a very dangerous situation because after flashover, the fire tends to spread rapidly throughout the facility. Firefighters are trained to and have protective clothing to deal with flashover situations. A facility caregiver's residence would not have any protection, and it would be lethally dangerous to be in any type of situation where a flashover would occur. So we are very interested in communicating to all of the CBRF people and residents that they must get out of a building prior to any growth stage or free burning stage of a fire. Smoke and fire gases will continue to collect at the ceiling after the free burning phase. And as long as windows and doors and the facility stays intact, the fire would burn until finally it starts entering into what we call our third stage, or our smoldering stage of fire. Now that we have talked about the free burning or growth stage, there's an important point that I need to make before we go on into the next stage. The free burning or growth stage, there's a time element from the start of the fire through the free burning stage to the smoldering stage or the third stage. The important thing to remember is that your time to get out is very limited. From the time the fire starts to the time where you may not be able to get out of a room is 2 to 5 minutes. It's important to note that within the first 2 minutes, your life safety is going to be very, very important, and that's the time that you need to work with to get out of your facility. After that time, the fire will develop in such a case that it will prohibit people from getting out of the facility. If we talk about the third stage of the fire, an important point to make now is that in the second and the third stage is that your ability to extinguish the fire is going to be very unlikely. The fire has grown to a size that most of the extinguishing agent that you have available to you is not going to be enough, and your personal safety is more important to get out of the facility than it is to fight a fire. With the third stage of the fire is our smoldering or decay stage. An important thing to note to remember is that the only way we get to the third stage is by the fire burning up the oxygen in the facility. Closed doors and closed corridors or limited area is going to burn up the fuel quicker and put the fire into the smoldering stage. If doors are open and windows are open, that fire will continue to burn, and eventually the building will burn until the fuel is all used up. In the smoldering stage is an important point that we call backdraft. Backdraft is an actual smoke explosion. The likelihood of a backdraft occurring while you're in a facility is very, very rare, although it can happen, especially if a fire is in a contained area such as a basement or in a room where it's well confined from the other home and someone were to open up the door. We need to talk about a few things about backdraft and signs that you need to look for in the event that you do have one. First of all, a backdraft situation is smoke under pressure. As the smoke rises and builds, it is lacking for oxygen. An open door can give it that oxygen, and that pressure would be released then through that avenue. Black smoke becomes very dense and gray and yellow in color. The gray and yellow is an indication that it is in fact starving for air, and is an incomplete type of combustion process. In a confinement situation behind a closed door, it can have excessive heat. A tremendous amount of heat can create a situation where there would be little or no visible flame. Again, as the flame burns up the oxygen, the flame starts to go out. What does remain, though, is the tremendous amount of heat in the area. Smoke leaves the confined area in puffs or in intervals, in areas that you have under a door, in transoms, around windows. Firefighters typically see smoke puffing out of eaves or the soffit vents or in any type of vent in your attic areas. Those are all signs of backdraft. You'd also could have very muffled sounds. Again, it's very hot and it's very dense in smoke. So you would get muffled sounds of popping glass or shifting drywall and making cracks, things starting to burn would make those types of sounds. Typically, those are sounds that you would not hear in that situation because it would be very difficult to survive. It really is impossible for anyone to survive this type of environment. Rescue is our only course of action. The fire department is going to have to vent the building and get in quickly with hose lines and breathing apparatus to rescue anybody left inside a facility in the smoldering or decay stage. The smoke can act as an explosion causing injury to anybody nearby. It can occur in a building or in a single room. It is very, very dangerous. A CBRF caregiver can minimize the threat of fire situation by being very cautious to opening any doors during your evacuation. Feeling the doors with your hand, feeling the doors for heat, being very cautious about opening any doors where a fire may be behind would certainly save you from a backdraft type explosion. If air is introduced to that space, it goes back to its actual second stage or free burning stage. As long as air is continued to enter in the facility, again, the wood and the fuels and the hot gases would ignite and the fire would free burn until the fuel is used up. Some of the factors that will affect the development of a fire in the three different stages are the size and number of the arrangement of the type of ventilation openings. Of course, the larger size of the room, the more ventilation that would be required to get the hot gases and fire out. Windows and doors that are left open will help spread the fire. The size of the room would indicate the size of the fire. Of course, a larger room with a lot of fuel would create a bigger fire than a small room with very little or no fuel in it. The size and composition of the fuel itself. As I said, flammable liquids tend to burn quickly and more rapid as they're spread out over a floor than would a pile of newspapers sitting on a chair. The types of wall coverings or types of furniture that you have, depending upon the material, that would also dictate the rapidness of a fire spread throughout the building. The more wall covers and things that you have, draperies, the more things that you have hanging from ceilings, in a fire situation, the faster the fire would grow and the more rapid it would spread throughout the facility. The availability and location of the fuel packages are called target fuels in the fire service. These are things like rack storage, flammable liquid storages, etc. That fire spread would then go through the facility, and that takes us really to the next part of our discussion in talking about fire spread in the ways that it will go through. The fire is going to continue to spread throughout a facility as long as nobody puts that fire out. And it spreads in a number of different ways. We need to think about those ways that it spreads because a facility person or a caregiver can limit the spread of fire by doing a few important things. First of all, let's talk about the way fire spreads. The first thing is conduction. Conduction really is the point-to-point transmission of heat through a particular object, usually a solid type object. It can take place during the beginning incipient phase, or it can take place in the stages as the fire grows. It's the transfer of heat through a material. It's also the direct contact between two bodies of heat. Metal is, of course, is an excellent conductor and will transfer heat faster than wood, which is a very poor conductor. The next type of way heat transfers is also the most common and dangerous way, is convection. Convection is the natural flow of air currents or heat throughout a building. Of course, if we think about fire spread, if you take a look at the way smoke normally goes, we think of smoke going up first and then out. If a fire grows in a facility, it will do the same thing. It will grow and go up to the ceiling, and as it hits the ceiling, it'll start to spread across the ceiling and then out through doors, or it'll collect and build and grow down through to the floor. The fire in the room will generally hit the ceiling and then create what we call a mushroom type effect. There will be a lower amount of heat at the floor and, of course, a higher amount of heat at the ceiling level. Occupants, when evacuating from a condition like this, should understand that they need to stay very, very low to the floor. That's where the cool air is, and that's where the good supply of oxygen is as well. The ceiling height is a definite factor of how fast that fire will spread. The larger the fire would grow, it would collect at the ceiling, and the height would have a definite bearing on that spread of fire. CBRFs with multiple floors need to take this into consideration when developing their emergency evacuation plan. As the fire grows on the first floor, stairways will automatically take that heat and smoke up to the second or third stories as it burns. If a fire has an inadequate fuel and oxygen supply, it will continue to spread vertically, and then, of course, it would spread horizontally. Doors and walls can prevent a fire from spreading. A solid door can protect occupants for an undetermined amount of time while they evacuate the building. The more secure the door is, or rated the door is, the longer it will hold a fire back. Many times facilities have fire-rated doors in areas such as the basement levels or any types of heating areas that they would have in their facility. But convection by far spreads very fast and rapid, and it's absolutely important that occupants get out of the facility or they're going to be confined to their particular room. The next way that fire would spread is what we call radiation. Really, this is the transmission of energy as electromagnetic type waves. Examples might include light waves, radio waves, or X-rays. Although radiation is not as common, especially inside a building, it's more common with exposures when firefighters are fighting fires. Sometimes homes that are relatively close in proximity to one another will result in fires spreading to other areas because the radiant heat will affect those other buildings. Firefighters generally rely heavily on water to cool those surfaces of any materials that would be considered exposures. If you take your hand and you hold it near a fire, it gets hot. As you put your hand closer to the fire, the hotter it gets. That is what we would call radiant heat. Radiant heat is not affected by air currents. It also travels through non-opaque objects. A window is an example. Radiant heat can transfer through a window. Radiant waves bring materials to their ignition temperature. As we said before, as the materials are heated up, the vapors of those materials are being given off. The materials can produce enough vapors to ignite. If the vapors find the ignition source or the open flame, the area will start on fire. In large fires, it's possible for that radiant heat to ignite other buildings that are quite a distance away. Of course, in a facility, our main concern is that you are out of the building at this point in time and well away from any type of fire that is occurring. We really need to identify the types or classes of fires that there are. When we talk about classes of fires, there are basically 4 classes. The first one is called the Class A, or ordinary combustible class. These types of examples of ordinary combustibles would be wood, cloth, paper, rubber, and plastics. In your facility, I'm sure you could look around and find a number of these examples. A Class B is our second class, and Class B is flammable and combustible type liquids. Examples of those that you might find in a facility are gasoline, oil, lacquers or paint thinners. Natural gas is also considered a Class B, and or petroleum type gases. All of those, depending upon their state, whether they're liquid or gas, would depend on their volatility. Those are Class B fires. Class C is energized electrical. The important thing to remember with energized electrical is that the only reason it has this class rating is because it is considered to be electrical. Once we shut the electricity off or unplug the item, it would go back to either a Class A or Class B. Class C, or energized electrical, in the facility would be any appliance, computers, transformers, any wiring that you might have in the CBRF would be considered energized electrical. The fourth class that we'd like to talk about is Class D, or combustible or flammable metals. This class is very rare in home setting or in a CBRF. Types of examples, though, you'd find is aluminum, magnesium, titanium, and again, it's more commonly found in industrial type settings. Class D fires, since they're very rarely found in homes and they take a very specialized material to extinguish them, we are going to cover that material as far as the extinguishing agent to the point where we just understand what the class is. The next part of this unit is the fire extinguishment part. Fire extinguishment, as far as the CBRF is concerned, is primarily fire extinguishers. Fire extinguishers are designed to put out specific classes of fire. They can either assist you, they could hinder you, or they could endanger you in your endeavors to extinguish a fire. Portable fire extinguishers are designed to extinguish beginning or incipient fires. They may be very ineffective on fires in the other stages. Fire extinguishers are only good on the classes that they're designed to put out. The CBRF needs to look at the types of fuels that you have in your facility, and you need to identify which extinguishers are going to best extinguish those types of fuels. When we think about fire extinguishment, we identify between putting out a fire and eliminating one or three of those sides of the fire triangle. The first type that we'll discuss is the cooling of the heat side. Of course, and a good example of that is putting water on a waste paper basket fire. It works best on Class A type fires, which was ordinary wood and combustible type materials. Remembering that you never want to put water on an energized electrical type fire. The second part of that is removing the fuel. Removing the fuel, is best example is works on Class B type fires. In gasoline type fires or liquid fires, or in gas type fires, shutting off the gas or eliminating the flow of the gasoline would work the best and is a perfect example of removing the fuel. On the oxygen side of the triangle, we talk about smothering. When we smother a fire, what works best is the Class A or Class B type fires. A good example of that might be closing a door, shutting off the fuel supply for the fire to burn, or if we shut off putting a cookie sheet over top of a burning pan, or if we put a pillow in a particular waste paper basket, might be an example. Stopping the chemical chain reaction was the fourth side we talked about. That really takes a special type of an extinguisher, or the multi-purpose dry chemical extinguisher. So the types of extinguishers that we need to look at are the most common ones that you would have in your facility. Although a number of different manufacturers are out there for extinguishers, they're really designed to work basically the same, based on the type of extinguisher you have and the type of classes that that extinguisher would put out. First of all, the Class A type extinguisher is most common a pressurized water extinguisher. The pressurized water extinguisher holds 2.5 gallons. It's put under pressure, and as you squeeze the handle, the water comes out and onto the fire under pressure. It's a very good extinguisher to use when you're going to cool a particular fire. The second type of extinguisher that we'll talk about is a dry chemical fire extinguisher. There are a number of different types of dry chemical fire extinguishers. We talk about a Class BC and a Class ABC. Most of your dry chemical extinguishers would look very similar to this one. Based on the type, would indicate the classes of fire to put out. Dry chemical fire extinguishers are extinguishers that have a chemical put in under pressure. Again, as you squeeze the handle, the amount of the material will come out of the hose and then onto the fire. The next type of class and extinguisher is the CO2 fire extinguisher. The CO2 fire extinguisher is a Class BC. CO2 extinguishers, the material inside is put in as a liquid and it comes out as a gas. Again, by squeezing the handle, the gas would come out and basically smother the type of fire. CO inhibits the oxygen at the fire level and it will smother and put the fire out. And then finally, the chemical chain reaction of fire, or if we talk about the Class D fires, Class D fires are dry powder. Dry powder extinguishers, although I do not have a example up here, are primarily designed for a specific type of metal burning. That particular type of metal, which is very rare, of course, in facilities, would be identified by a company, and that company would provide the appropriate material to extinguish that particular fire. Again, it's very rare that you'd find this in your facility, and we're going to concentrate our efforts today on the ABC type extinguishers. So let's take a look at the multi-purpose dry chemical fire extinguisher. The multi-purpose dry chemical fire extinguisher is good on an A, B, and C. The minimum requirements for your facility with a dry chemical fire extinguisher is a 2A, 10B, C, which means that the extinguisher must have 2 times the capabilities of a water extinguisher, or 2.5 gallons of water for Class A. It would have to have 10B, which is 10 square feet of burning surface on a Class B fire. And the third thing, it has to be a material that will not conduct electricity. So 2A 10BC is a minimum requirement. Of course, there are larger size extinguishers, and the larger size extinguisher is only going to provide more protection. Again, I want to be specific about using fire extinguishers only on incipient type fires. The multi-purpose dry chemical fire extinguisher is most common simply because it puts out the 3 classes of fire. You can imagine trying to pick and choose between the 3 different types of extinguishers that I have here for a particular class of fire. Most operations require the ABC because it's easy for the operator to just go to an extinguisher, understanding that that extinguisher will put out all of the classes of fire that most of the facilities have. Some of the important points to make about this particular extinguisher is that the extinguisher should be located on all of the floors. The requirements for CBRF facilities also require extinguishers that are on upper floors be close to the head of each stairway. Extinguishers shall be located so that they do not exceed a 3,000 square foot area of the facility. Again, the extinguisher material is only good enough to put out so much amount of fire. The other thing that is important about extinguishers is that they need to be relatively close to one another so the operator does not have to travel great distances to get to a fire extinguisher. The actual travel distance per the code is not more than 75 feet. In some of your larger CBRFs, it is common to find a number of different types of extinguishers, simply because larger facilities have the greater chance or potential for different types of fuels. Water extinguishers may be located on every floor or in various areas of corridors of your facility. fire extinguishers may be located also in various cabinets. It's important to note that cabinets should not be locked. They should be accessible at all times. And the operator needs to understand of the types of extinguishers that are located in each cabinet. CO2 extinguishers may be located where actual electrical equipment is found. Sometimes facilities put a specific type of extinguisher near a specific type of fuel. It's also not uncommon to have a halon type, which is a BC class extinguisher, located next to expensive electric equipment, computers, things of that sort, because that type of agent does less damage when it is expelled on those types of fires. So whether your facility is large or whether it is small, each operator needs to understand where the extinguishers are, what types of extinguishers are good for the classes of fire, and also how to operate each extinguisher. Fire extinguishers must be maintained on a regular basis by the facility. It's important that they're inspected on a yearly basis and serviced by a service contractor. Although there are a number of different types of extinguishers in your facility, I'm going to pay particular attention to the multi-purpose or ABC type extinguisher. Although the water extinguisher is also effective on the fire, and the CO extinguisher is also effective, the multi-purpose dry chemical fire extinguisher is the one that most facilities will find. When you take a look at your extinguisher, if you examine it, it has a number of different parts on the extinguisher. Of course, the cylinder has the powder that's inside. It also has a gauge at the front of the extinguisher. It has a pin in the handle that keeps the extinguisher from going off inadvertently when you don't want it to. And then it has a hose that's used to apply the agent onto the particular fire. In addition to those parts, it should have a tag on it, and that particular tag will indicate when it was last serviced and checked. And also there may be some manufacturer's information that is applied to that particular extinguisher. When you take a look at the extinguisher, all of those parts should look like they're intact. The extinguisher should be in ready condition. There's an arrow at the top of the gauge that should indicate in the green section, which says the extinguisher is pressurized and ready to go. In addition to that, the extinguisher should be hung on the wall or placed in a particular cabinet, and it should be well marked. The top of the extinguisher, if it's mounted on a wall, should not be any higher than 5 feet from the floor, making it easy for anybody in the facility to remove that from the wall bracket. It's also important that the extinguisher not be tied down, locked in a cabinet, closet, or placed on the floor. Extinguishers should be clearly marked wherever they're located, and they should be used exclusively for the class of fire that they are rated for. You always want to know when and when not to extinguish a fire. We said a couple times in this program that extinguishers are only for small fires, and I can't emphasize that enough. The emphasis really should be on personnel safety, not only the people that are in the facility, but of course yourselves. You want to remember that an extinguisher is only good as the operator utilizing that particular appliance. It's not every day that people get a chance to go out and use fire extinguishers. If you haven't used one, how can you operate one in the middle of a crisis when there is a fire burning out of hand? So I encourage you to get some practice and learn or see your local fire department in understanding fire extinguisher use. The very first thing you want to do if you do have a fire and you think you may need to use a fire extinguisher is to identify, of course, what type of fire is burning. That really should be taken care of in the start because, as I said, the ABC multi-purpose dry chemical fire extinguisher will work in all cases. Perhaps not as well in some classes than in others, but it will in fact put out each class of fire. When you want to use the fire extinguisher, you have to remember that you need to remain a safe distance from that fire so that you do not get in contact with any of that radiant heat that we had talked about earlier. The circumstances that you would not use a fire extinguisher to fight a fire would be if that fire is spread beyond the incipient stage and extreme heat and smoke is present, if you cannot have your back to an exit or be relatively close to the escape exit, if you have a very limited amount of knowledge or you don't feel comfortable with utilizing the extinguisher, or if you had evacuation considerations that took a higher precedent in the case. Again, extinguishers are important, but they're only as important that other people are exiting the building and get out safely. If you need to use the extinguisher, there's a couple of steps that you need to take. First of all, you need to go and get the extinguisher from the nearest point. You need to return with that extinguisher, and you need to stay well enough away from the fire so that you can test the fire extinguisher and put that extinguisher into operation. To put the extinguisher into operation, there are a number of steps that you need to take. There's an acronym called PASS, P-A-S-S, and that PASS stands for a number of steps that need to be taken. First of all, the P stands for pulling the pin. On the extinguisher, the pin is located at the top of the handle. It holds the handle from inadvertently squeezing down and releasing the agent, and that pin is held in by a small plastic tab that's put on by the service company. Once that plastic tab is real easy to pull the pin out and release the mechanism for squeezing the handle. The very next thing you need to do is the A, or aim that fire extinguisher at the flames. Now, considering that the extinguisher was just used, you want to test the extinguisher and then apply your agent onto the fire, remembering that each extinguisher does not need to be right next to the fire. You can be well away from a fire and still apply the agent. You would take the nozzle and aim that extinguisher at the base of the fire. The base of the fire is where the fire initially started, at the floor, in a garbage can, in a waste paper basket. Those are considered the base of the fire, or the base of the flames, if you will. You would then do the S part, which is squeeze the trigger while holding your extinguisher. Keep in mind that the extinguishers are under pressure. It's not anything to be afraid of. The extinguishing agent will come out on its own, but you need to have control of the nozzle. If you don't hold on to the nozzle in the extinguisher, that nozzle will whip around and injury can occur. You would press the handle and you would apply the agent at the fire. The last S stands for sweeping that fire extinguisher. As you apply the agent, you would sweep it in a very fast or very rapid motion at the base of the fire. You would also expel the entire contents of that extinguisher on that particular fire. Some of the important points to remember about utilizing fire extinguishers in fire is that you want to leave the area immediately if a number of these issues would occur. First of all, if your path of escape is threatened at all times, or any time I should say, you want to exit the building immediately. Second of all, if your extinguisher runs out of agent, the extinguishers are only filled with so much agent that once that agent runs out, you will not have time to go back and get another extinguisher. You will leave that extinguisher and leave the premises immedately. The third thing is if the extinguisher provides to be ineffective on the fire. Again, an ABC multi-purpose dry chemical fire extinguisher is rated for 3 classes of fire. The fire may be at a point where the extinguisher, or you find the extinguisher, is not being effective. If those flames don't go out and that it does not provide a clear view of the smoke, you should exit the building immediately. If you no longer are able to fight the fire, again, we're talking about just a matter of seconds here, and if at any point in time you feel uncomfortable, we would like you to exit the building as soon as possible. An important thing to remember is that a fire is causing damage is not nearly as an issue as is injury to you or the people that are in your facility. We want to bring home the point that the extinguisher is good, but it's even better if everybody gets out safely. The third point I would like to make is that it's important that once your extinguishers are used, or if you find an extinguisher where the gauge is not appropriate, or the extinguisher agent has been discharged either on a fire or inadvertently, it is important that the extinguisher be sent to a service contractor to be recharged before it is hung back on the wall. Upon completion of this course, we would like you to take a look at your facility, take a look at the types of extinguishers that you have at your CBRF, locate those extinguishers, get a picture in your mind where they're actually at in the facility, and find out what types of extinguishers, who manufacture them, what's inside. All of that is on the label in the front of the extinguisher. It's all indicated. You can look at the gauge, you can look at how the hose and all of the parts of the extinguisher work. In that way, if a fire does occur in your facility, you're going to be much more comfortable with utilizing that type of extinguisher. We've just talked a lot about fire extinguishers. There are a few things that you can do if you do not have a fire extinguisher readily available. Of course, it's a point that I need to make that extinguisher is the best means of extinguishing a fire, but if you have some of these other things, it may work for you as well. First of all, when we're talking about improvised fire extinguishers, it's important to remember that safety is the most important concern. One of the ways that you can use, if you have baking soda out and it's available, sprinkling baking soda over top of a fire on a stove may reduce the flames for you. Another way to do it is if you're cooking in a pan. If I take the pan and I slide the cover on top of the pan, I would smother the fire, and then removing the pan from the heat would help reduce the possibility of safety for you there, or injury. If you take a cookie sheet that is relatively available in the kitchen, again, if it's there, you can use it by covering that same pan. A cookie sheet on top of the pan is going to reduce your flames, and although it may not put the fire out, by removing that pan, of course, from the heat, it make it easier for you to manage that type of emergency. The last way that I'd like to show you is utilizing an ordinary pillow in a fire situation. Now, in most cases, you would think that pillows can burn, and that's absolutely true. Pillows can burn, and you want to be very careful about utilizing pillows in putting out fires. Pillows are not designed to bang or stomp out on fires because they'll spread the fire and they'll catch the pillow on fire, and with that wind type of blowing, it'll increase the fire size. What I'm talking about using pillows in more of a smothering type effect. And it's not just pillows. You could use a wad of bed sheets. You could use a blanket. All of those would work, is where you would have a closed container fire. And you take that pillow, by setting that pillow on that fire, again, may not put the fire out, but certainly will give you more time to exit the building or to go get an extinguisher that would be more appropriate, such as cooling the type of fire. These types of improvised extinguishers, again, are not the best way to put out a fire, but nevertheless may work in a pinch if you do not have an extinguisher available. There are some other things that we also would like to talk about that would not help you in a fire, or in fact make the situation worse. Some of these home remedies to fire extinguishers have been talked about over years, and you may even have heard these in conversation before. But what we don't want you to use is things like flour. Flour, because of its fine nature, can explode if you put flour over an open flame, which would cause more injury to you. Another thing is salt. People think that sprinkling salt over a fire is going to put it out. Salt would be ineffective. In fact, in many cases, you wouldn't have enough salt to really do you any good in terms of a fire. So it's not recommended that you use salt. Baking powder is another type of product. Now, we had talked about baking soda as being effective. Baking powder would be ineffective, and again, like flour, it could explode. We had said using water on a Class A fire would be effective. However, using water on greases or flammable liquids would be very ineffective. In fact, it would cause a violent reaction, and it's very possible that you could burn yourself in the process. Also, water on an electrical fire could cause an electrocution or a shock. So we want to keep water away from any energized electrical equipment. The important note to make with that is that anytime you have an energized electrical situation, you want to either unplug the appliance or turn off the circuit breaker, or just leave it go, evacuate the area, and allow the fire department to handle it if you're not sure if it's electrical or not. The only way you know if it's safe is if you unplug it. What we've really been talking about here is cooking safety. Many of your accidents will occur around the kitchen area. Many injuries are reported in using cooking type appliances. And fire safety is equally as important when using these appliances. Anytime you're working on an oven, you want to shut that oven off if you have a fire. Removing a pan from the heating element is important. Turning the gas off if gas is flowing is important. As easy as leaving your oven door shut if you do have a fire inside your oven, and shutting off the appliance itself is much better than trying to open up the door and apply an extinguishing agent to it, or remove that burning object to an outside location, or try to cool it. Many times fire departments respond on types of a situation like this, and the end result is somebody getting burned or a fire spreading throughout your home. Remember, when you're working with any types of cooking appliances, they are hot. There is a potential for an emergency to happen. Use wise decisions, common sense, and safety when cooking. If you would like to learn more about fire extinguishers and operating a fire extinguisher, you can get more experience from your local fire department or the VOTEC system in your district. The other thing we'd like to let you know is that there are a number of videos available on fire extinguishers. One video that I can think of that is very good is the National Fire Protection Association puts out a video called Flight or Fight. That video may be obtained through your facility if you have access to it. I encourage you to watch that video because it shows you more on fire extinguishers, and it has a good demonstration on how to use fire extinguishers. In this next unit, we're going to cover fire detection and alarms. Every facility, large or small, needs to have a detection system in place. It provides the earliest warning of any type of fire. There are a number of different types of detectors that you can have in your facility, and I'm going to cover a few of those examples. The first one I'd like to talk about is one of the most common types, and that is a smoke detection system. Smoke detection systems are designed to sense smoke or burning process and then provide early warning for you to get out of the building or alert you to the presence of a possible fire. The first type of smoke detector that we're going to talk about is the ionization type detector. It's important to note that it's very difficult to tell the difference between ionization detectors and some of the other types that I'll cover in a minute. It's more important that you know that it's manufactured and tested that is appropriate for your facility. First of all, the ionization detector detects products of combustion that's present. They generally respond better to flaming type fires versus smoldering type fires. And they also will reset themselves after they have been set off. Other types of smoke detectors are photoelectric type detectors. Photoelectric type detectors detect carbon particles in the smoke. Generally, they are more sensitive to smoldering type fires than they are to flaming type fires. They also will reset themselves automatically after they have been set off. Some of the information that you need to hear about with smoke detectors is that, first of all, they react very fast to products of combustion. They must be interconnected. When we talk about interconnected smoke detectors, that means that each one is connected to the other, and they all set off a general alarm that everybody can hear in the event of a fire. And they may be connected to a monitoring station somewhere inside your facility. Smoke detectors also must be located on every level of the home. Multi-story buildings need smoke detectors on every level, and in addition to that, they should be very close to the head of every open stairway. They should be placed no further than 30 feet apart and not further than 15 feet from any wall. They also should be in common rooms, such as family rooms, recreational areas, and in all of the bedrooms in your facility. They should be tested and cleaned on a regular basis per state code or per the manufacturer's guidelines. Remembering that smoking, cooking, and even fireplaces can cause nuisance alarms and set these detectors off inadvertently. If there are no obvious reason for a nuisance alarm, you should always remember that anytime the smoke detector goes off, it actually could be a fire. If a fire is occurring in your facility, it's usually in the incipient or small stage, and action needs to be taken immediately. Taking the time to go determine exactly what the fire would be, or if there is a fire at all, would take away from the time that people would evacuate the property. Remember, when a smoke alarm sounds, there's a reason for that. Always respond to a smoke detector as if there was an actual fire. Another type of detection system that we need to cover are heat detectors. Heat detectors operate very differently than smoke detectors operate in that they work on the basis of the heat that's developed in a fire situation. Some of the oldest types in use of heat detectors are still in use today and work on the same principle of the rise of heat. Because heat rises, they must be placed in a high place where, such as ceilings or walls at the top near the ceilings. They are usually placed in kitchens and furnace rooms because those are the places where heat is more common than in other parts of the rooms. They are also placed there because they're less likely to create nuisance alarms as smoke detectors would. They should be installed in attached garages, attics, and enclosed furnace rooms and laundry rooms. They must be tested and cleaned just like smoke detectors would be taken care of, and they also should be tested and maintained per code or manufactured guidelines. It's important to know that heat detectors may not be resetting as the smoke detectors were, and that they should be replaced after heat detectors go off by a proper service representative. Some of the types of heat detectors that you'll find, there's basically two different types. The most common types are, one, the fixed temperature heat detector, and two, the rate of rise heat detector. With the fixed temperature heat detector, the principle behind it is that as the temperature rises, it gets to a certain point, and that detector will go off. Usually it's the type of a detector that will have a heat sensing or thermal sensing device, and as that heat gets to that point, that thermal sensing device will trigger the alarm. Fixed temperature detectors of the detectors are the oldest types manufactured. They are the most inexpensive type detectors to purchase. They are least prone to faulty activation, but they are the slowest to activate of all the various detectors that we talk about. And they are not activated by smoke or fire gases as the smoke detectors are. The second type is the rate of rise heat detector. These types of detectors operate on the basis that temperature will increase faster from a fire than in the normal types of temperatures where they're located. They're designed to emit a signal alarm when the temperature raises to a point that exceeds 12 to 15 degrees in Fahrenheit, degrees per minute Fahrenheit. Most are reliable and not subject to false alarms. They also work faster than a fixed temperature heat detector would. This does not work as fast, of course, as a smoke detector, and if it's not properly installed, they can activate in non-fire type conditions. Rate of rise heat detectors are put in areas such as the furnace room or areas where heat tends to fluctuate on a regular basis, but certainly would not be enough heat that would create an emergency. Lastly, we would like to talk about manual pull stations. Manual pull stations are required usually in larger CBRFs, although it's not uncommon to find them in the smaller ones as well. They are not activated by any products of combustion. It's important to know that manual alarms work just as that indicates, and that is if there's a fire, someone has to pull that alarm. They're also what we consider a local alarm usually. A local alarm means that when they're activated, only alarm at that particular property will sound. Although some of the more expensive units and the larger facilities do have them connected to a central station or their local fire department who monitors that alarm. So essentially when somebody pulls that alarm, it goes to that station or it goes to the fire department and somebody is alerted that there's an emergency on the property. Local alarms should be, pull stations should be located near your exits or in corridors, off your areas where you would sleep. They also may be found in large areas or individual rooms. Other types of alarms that you may find in a facility would be more appropriate for the type of residence that you have. Some of the special alarm equipment that we'll mention in this particular course is particularly for the hearing impaired or people that have a difficult time with their vision. High intensity strobe lights would go off if a fire was in a room. Again, this type of mechanism would be set up with some type of a smoke detection system. Or a variable speed fan would go off to alert somebody that there's a fire. Or lastly, vibrators in the beds would cause the person to wake up and be alerted to the fact that a fire might be present. Again, these are special type alarm systems. They're not required. However, they are important for types of people that you have in your facility that are not able to respond to a normal alerting device such as a smoke detector. The next unit we're going to cover in this course is about fire suppression systems. Basically what we're talking about is fire sprinklers or chemical suppression type systems. The first one we'll talk about is sprinkler systems. Of course, they're the most reliable of all extinguishing systems available to you. There has never been a major life loss in a facility that had an operating fire sprinkler system. They're 98% effective in either controlling the fire or completely extinguishing the fire, and they're usually activated by heat sensing devices. They're connected to a detection system that alerts the fire department, and they must be serviced by a qualified sprinkler contractor. It's important to note that only authorized persons may shut off sprinkler type valves in your facility, and that they be inspected, maintained per code and manufactured guidelines. The two types of sprinkler systems that we'll talk about today is the wet type and the dry type. The wet type sprinkler system is nothing more than water under pressure, and it's released by heads that are located throughout the facility. The facility could have a partial sprinkler system where all the major halls, corridors, and living areas would be sprinkled, or it might be a full sprinklered system where the complete sprinkler systems would be located in resident rooms and other areas as well. Wet sprinkler systems are the most common that you find in protection systems, and they have various number of heads depending upon the amount of area that the sprinkler system covers. The important thing to remember about the sprinkler heads are that they are there and they're always available and they're always energized, so at any point in time a fire would start, that water would come out and extinguish the fire. The difference between the wet type and the dry type really is nothing more than in the dry type system the water is replaced by air, and that's primarily because of climate conditions. Water will freeze, and in cold or inclement weather the systems are put in the dry mode. In the dry type system, the system is kept pressurized with a compressor, and that compressor is always operating, keeping the water back. When the sprinkler head goes off, the air is replaced by the water, and it operates basically the same as the wet system operates. When the fire is detected, the water is expelled and cascades over the fire area. In chemical systems, they work a little differently. Chemical systems are found primarily in areas where they have specialized needs. One of those areas might be a kitchen or exhaust system over a large cooking facility. Chemical systems are the most expensive of the systems out there, and they're commonly found in appliances that you would have. They're a special agent under pressure, and they are special heads that are designed to disperse that agent out over the fire area or in the hood area of the facility. They are released usually by a heat detection system, or they may be operated by pull stations. In the event that one is inadvertently goes off, there always is a delay where one may stop the system from going off by pushing a stop button on the pull station. They must be restored by a qualified service company, and anytime the system does go off, the amount of cleanup that is necessary is usually substantial. In those particular circumstances, usually the state departments of health need to be contacted for any types of cleanup. Usually with those systems, if they go off, your kitchen facilities are down for an extended period of time. Now that we've finished talking about alarm systems and suppression systems, there's one thing that I would like to bring out, and that is an important point to remember when dealing with any type of alarm that you have in your facility. First of all, any alarm you have, until determined otherwise, is a true or actual fire alarm. Sometimes alarms will malfunction. Sometimes you will get nuisance alarms. But the one thing we don't want to have happen is somebody not think it's a real alarm and then delay any time in evacuating the property. It's also important to remember that you're working in conjunction with the fire department anytime alarm is going off. If there is a malfunction in your alarm system, we want to find out exactly why that's malfunctioning. In order to do that, we need to come to the facility and we need to identify the head that's going off, or the problem if it was. Also, you need to be assured that the manufacturer or the service people of that alarm system need to be contacted immediately to put your property back into service. What we don't want to have is a facility without a detection system for a number of days until the alarm company or the service representative can fix your system. Above all, when the system goes off, please be assured that people will respond to your facility when called, and that the facility needs to be protected at all times. In our next unit, we're going to cover some of the basic safety procedures that you should take in the event that you have a fire. You need to protect yourself from fire or from smoke when there's a fire. And there are certain things that will help you or help to protect yourself from those types of circumstances. The first one is that anytime the alarm goes off, we teach people to roll out of bed and crawl to a door. When you're alerted at night, in the middle of the night, and you're awakened to a smoke detector going off, if you don't roll out of the bed, if you were to sit up or stand up in those circumstances, you might be standing up in a smoke condition. When you roll out of bed, you stay low on the floor. Anytime you're evacuating from a facility in a fire situation where there is smoke present, you want to stay down below the smoke levels. Staying at the floor where it's cool and where the most of the air is will help you survive and help you to find your way out. Much easier than walking and coughing through a smoke type situation. Anytime you have a door in your path, you need to make sure that you feel that door for heat. It's not uncommon to have a fire situation on the opposite side of a door. You want to feel the door by starting at the bottom of the door and then working your way up. It's best to use the back side of your hand because that's more sensitive than the front side to a heat situation. Remember to be very cautious about touching any types of metal objects on the door, doorknobs and things like that until you feel close to them because of they can produce heat from the other side of the door. You want to be very cautious about opening any door where you suspect a fire on the other side. Remembering that term backdraft that we talked about, we want to be careful that you don't open up that door and create a backdraft situation. Sometimes opening a door for just a second can cause so much fire and smoke to come through, it'll make your evacuation to an alternative route much more difficult. Remembering that as you exit the building, you want to close those doors behind you, cutting off that fire or that travel of fire. A closed door can give you more time to exit a building, and quite honestly, it contains the fire to one area and makes it easier on the firefighter to locate the fire and extinguish it. You want to make sure that everybody meets at a pre-designated place outside and well away from your facility, making sure that people have the appropriate needs for care. If it's cold out or if it's raining or storms, those are considerations that need to be made, and those are things we'll talk about in the emergency preparedness part of this course. When you're out at that pre-designated meeting place, you want to make sure that you have a count of all of the people that you're caring for, including visitors. Yet at any time, if there's unsuspecting a person getting out of a building, that information needs to be relayed to the fire department upon their arrival. And above all, never, ever, ever go back into a facility or into your building before the fire department says it's okay. Sometimes you'll want to go back in, you forgot something. People think that they have time to go back, and we're in many, many cases, people lose their lives by going back into a building because the fire has spread beyond the point where we can safely do that. You want to tell the fire department when they arrive the location of the fire, how the fire started, and what's involved in the fire. It's important for the fire department to realize exactly what they're getting themselves into. It's also important to tell the fire department if there's possibly anybody inside. Sometimes you get outside the building and those thoughts run through your head. You're not sure if people got out or not. That's why it's absolutely critical that taking a head count and actually marking that down is important. And also keeping the people together or where you can account for them. There is one point to make with fire precautions during a fire. And it's not something that happens that often, but when it does, it is a true emergency. And it's one that you have to act very quickly. If your clothes ever caught on fire, a good procedure to take is to stop, drop, and roll to put the fire out. When you stop, that doesn't mean running away from the situation. It means stopping right where you are, dropping down to the floor, and then rolling from side to side to an attempt to extinguish the fire. We want you to also remember to cover your face with your hands to protect your face from the fire and also protect your lungs from getting smoke when you breathe in. Stopping, dropping, and rolling could prevent a number of burns on your body. That's also a procedure you not only do for yourself, but you would do for anybody else in your particular care. The second section that I'd like to talk about in this unit is actions to take actually during a fire. Sometimes people will come upon a fire and be surprised to the point where they don't have an idea what to do first, second, third, or fourth. A good way to remember the proper procedures to take is what we call the RACE system. That's R-A-C-E. In the RACE system, the R stands for rescue anyone in immediate danger. For the smaller facilities, that may mean getting everybody out of the facility. For the larger facilities, that may be getting people well away from the dangerous fire area. The second thing that we want you to do is activate the alarm and contact the fire department. For many of the facilities, that's automatically done with an interconnected system or with an interconnected smoke system that has an audible alarm. Nevertheless, we want that facility, other staff members, and other residents to immediately realize that there's an emergency at hand, that they need to get out. Time is of the essence here. The next thing that you can do, and we talked about this a number of times in the program, is that you contain the fire by closing the doors. That is so critical. It'll save time. It'll give you and your residents more time to get out of the building. And finally, as a last resort, you can extinguish the fire if it is small enough or in its incipient stage. If you feel comfortable with the fire extinguisher and you have one relatively nearby, extinguishing a fire can save you a lot of loss, especially dollar loss with the building later on. However, if it's a point where you don't think you can extinguish it, or you don't think the extinguisher is relatively close, or you don't have a good feeling about operating an extinguisher, it's important that that is a point in time when you immediately exit the building. A number of these safety procedures will help if you ever find a fire in your facility. It's important to have the smoke detectors to be alerted when there is a fire before the fire gets big is something that will help you out. It'll help your residents. It'll give you more time to get people out. However, there is a possibility, of course, that you would come across a fire and you would have to take appropriate actions. Remember RACE, R-A-C-E. Practice that, learn it, memorize it. If you have a fire, it will help substantially. In closing of this unit, an important point I'd like to bring out is contacting your local fire department. Certainly, it's hoped that your alarm system is connected with the fire department and they will be responding as soon as your alarms go off. However, some of the facilities may not be connected and need to contact the department. After everybody is out of the building and you contact your fire department, some of the things that they are going to require is your name, the name of the facility, your address and or your fire number. They're going to want to know if everyone is out of the building. They're also going to ask you questions in regards to the fire, where the fire is located. It's also important to note that any fire on your property should be reported to the fire department, and also any fire on the property must be reported to HFS within 3 days of that particular fire. In this next unit, we're going to be talking about fire evacuation. Throughout the program, we've stressed the importance of getting out of the facility safely when a fire has occurred. Although the CBRFs are required to be interconnected in terms of their smoke detectors will not put out the fires. It's absolutely essential that you and your residents evacuate the CBRF in the least amount of time possible. The minimum amount of room could be engulfed in fire is 2 minutes. However, it could be 1 to 2 minutes or even less than that, that smoke would fill the area and not permit people to escape the building. Some of the other limitations that you might find is that the growth or rate of the fire could be increasing depending upon the size of the room, the amount of fuel that is burning, and other variables such as doors and things of that sort. The location of the exits in relation to the fire is critical. The closer you are to the exit, obviously the less time it takes you to get out of the building. The other thing you need to realize is the fact that all of your residents have different capabilities in terms of exiting the building themselves, and they'll have to be assessed properly, which we will talk about later. The number of residents using each exit is going to possibly bottleneck the evacuation time, making it difficult for you to get out. And also, if you have any locked or blocked exits or pathways to those exits, it's going to limit the capabilities of people to get out safely. Obviously, the ideal situation would be for all CBRF residents to be instructed in proper evacuation procedures. We want the residents to save themselves as much as possible. Many CBRF residents do not have the mental or physical capabilities to do so. It's important that you assess those people and have a clear-cut idea on how they're going to react in a fire situation. Each time a new resident comes to the facility, they must be assessed for their ability to evacuate within 3 days of their arrival. It's important that you do an accurate assessment and keep an ongoing assessment of that resident's ability, because that may change from time to time. You may have frail or elderly people that are incapable of crawling or incapable of walking on their own. You may have dementia where people forget, or you may be utilizing some medications that limits the person's ability to get out safely. Some of your people could be emotionally disturbed. Some people might be mentally handicapped, visually impaired, or hearing impaired. Others may be non-ambulatory, and you may have some very uncooperative people at a time of an alarm. You're going to have to assess each person adequately to identify those limitations that the residents have. And it's important that you remember that, so you can key in on those people when you do have an evacuation or one is required. Many facilities keep ongoing records and logs located at the exit ways so that staff can utilize those during the time of an evacuation. Let's talk a little bit about the types of evacuation drills that you may be using. First of all, there are 4 kinds that are recognized in this program: the walkthrough, the announced, a surprise drill, and a full response drill. Each of them are different in a sense of how they're activated in your facility. First of all, the walkthrough drill is really designed for new residents in your facility. It's to assess new residents and staff and to give them a guideline on what to follow when evacuating. You must walk the new residents through the drill so they fully understand where the evacuations are, the route to get to each one of those evacuations, and any type of special procedures that you need to take with each resident. You need to show 2 means of exits. You'll have a primary exit and a secondary exit. In the event your primary exit is blocked off, your resident needs to know that they need to go to the secondary exit in the facility. You need to show that meeting place outside that is designated, that's well enough away from the facility that residents can get to in the summer and or the winter time when it's cold and there is snow out. The second type of a drill that we'll talk about is the announced drill. The announced drill is really for simulated nighttime drills, when you can assess the residents for their ability to awake, you can assess the residents for their ability to get up and get dressed, to roll out of bed and crawl to the door, feeling the doors, and those types of things that we had talked about in earlier units. You may also use the announced drill after each new resident has been trained through the walkthrough drill. Also, the announced drill is good to be used when residents are up and dressed and moving throughout the facility. Again, based on the residents' limitations, some of your residents you may be evacuating when they're up, but may stay in their room when they are in their room at night. The next drill we'll talk about is the surprise drill. A surprise drill may also be used when the residents are up in their dress. However, a surprise drill is going to give you a better indication on your times to get people out. Since that's the case, surprise drills may be used at any time during the day and would best assess your times in residence not only when they're sleeping, but when they're up and awake moving out throughout the facility during the day. It's helpful also to determine the actual time. It's best to take a stopwatch and get the time for each resident as they exit the building, not only realizing the difficulties that they may encounter, but also realizing how well they perform. The last drill we'll talk about is the full response drill. Full response drill is done, but it's important to note that it should be coordinated with your local fire department. The fire department should be contacted prior to any drills that you have and have them actually come out to the facility to walk through the drill and take a look at your emergency planning and evacuation criteria. It's also used to familiarize the fire department with the types of evacuation response that has been established in your CBRF. There are a number of fire departments that don't realize the amount of issues that CBRFs are dealing with elderly care and difficult in resident evacuation difficulties. It's also used to demonstrate the level of ability or difficult residence in the evacuations. It's also used when there is a serious question as to the effectiveness of the evacuation plan. It's used at the request of the local fire department. Sometimes the fire department will contact you and require you to do a full response drill for they can critique you. And it's also used at the request of the DHFS, who may come out on site and critique your evacuation as well. Some of the important things to remember during an evacuation fire drill, regardless of the type of drill that you're utilizing, is you need to note the amount of time it takes each resident to evacuate the building. You want to work with your residents to make sure that you can get better times with your residents. You want to improve their evacuation as much as you possibly can, remembering that really the only true way that somebody can survive a fire is by getting outside of the building. You want to note the number of residents with a greater time than 2 minutes on their evacuation time. Later on, the assessment of the 2-minute time is going to equate to the type of evacuation you might be doing. Residents with less than a 2-minute evacuation time may also find themselves in situations where evacuating is possible. Remember, it's just a time. It's not in a real fire situation. Real fire situations present and pose different circumstances that residents may take longer to evacuate, or in some cases, you may find that residents might surprise you and get out of the building sooner. Of course, it's difficult to assess in a real fire unless you have one. Hopefully that will never happen, but again, we want to emphasize the fact that you always are trying to improve your times of residents getting out of the building. CBRFs with connected alarm systems to the local fire department have an advantage because you don't have to go to the telephone and contact your local fire department until everybody is outside of the building. An interconnected system to the fire department assures you that the fire department is in response at the time of your alarm. That is so critical, and it's helpful for the smaller CBRFs who have a number of residents to evacuate in that short 2-minute time frame. Firefighters are going to need to know immediately which residents are trapped and where they're located. As you are outside by your meeting place, again, a head count is important. Make sure you have the people there. If you don't, let the fire department know that they aren't there. It's not uncommon where visitors are coming and taking residents out. They're going out for day trips, and there may be a situation where you have fewer or more residents than you actually had anticipated. It's virtually important for the CBRF to staff to know the fire prevention and precautions and actions to take during a fire. Remembering that RACE, R-A-C-E, is important and should be practiced when you find a fire, and it's also important to follow your emergency procedures and your emergency responses when you are found yourself in an evacuation situation. We have been talking about the 4 types of evacuation drills that a CBRF may use. It's important also to note the time frame it takes for your residents to evacuate, because there are a number of guidelines that relate to the amount of time that residents get out. For instance, if your residents are having difficulties getting out greater than two minutes, you may have to have sprinkler systems in your building. Some of the guidelines that are required is any external evacuation within the 2-minute time frame, your building need not be sprinklered. However, it still must have an operating interconnected smoke detection system. You must have a predetermined meeting place outside, which is a safe distance from the building. On an external evacuation that's within 2 to 4 minutes for your residents, the residents in the evacuation time for 1 or more residents in an unsprinkled CBRF is more than 2 minutes, and up to 4 minutes, the CBRF shall be incorporated with additional fire safety protections. The CBRF would need to be monitored by a direct link or line to the fire department. The CBRF would also need to have a complete smoke detection system throughout the building with a backup power supply. Multiple story CBRFs are required to have smoke separation walls between all floors, including the stairwells, atriums, vertical shafts, and also vertical openings. In addition, the ventilation systems are required to have automatic closures to prohibit the spread of smoke throughout the building. CBRFs that house residents that have an evacuation time of greater than 4 minutes are going to be needed to be completely sprinklered. They're going to have smoke separation between all floors, including the stairwells, atriums, vertical shafts, and vertical openings. And they also are required to have a 24-hour awake staff on duty. The other type is the external evacuation for what we call a point of rescue response. That type of response is used for residents who are unable to safely be evacuated, particularly when such residents are in their rooms when the fire department is sound. Remember, the assessment of the residents is absolutely critical at this time, because you may find that residents are unable or absolutely refuse to get out of a fire situation. Residents who are not in their rooms when the fire alarm sounds should be evacuated from the CBRF immediately. Residents who are not in their rooms should not return to their rooms and wait for rescue by the fire department, remembering that the only sure way to protect yourselves is to get out of the building. It can be used only in an approved CBRF that is sprinklered. So of the three types that we talked about, the 2-minute, the 2 to 4 minute, or the point of rescue response, the important thing to note that in any situation, the true way to stay alive is to get out of the building. However, a sprinkler system is going to protect you and give you time. Those residents that are not able to get out can be assured that the sprinkler system statistics show that in many cases it either controls the fire or puts the fire out. In summary to this unit on evacuation, it again is absolutely critical that you get out alive. You are to go to a meeting place outside the facility. Remember, stay with your people, keep the people there, contact the fire department as soon as they arrive and let them know what the situation is. It's important that you practice this. It's important that you assess your residents, and it's important that you get out safely. In this next section, we're going to talk about emergency planning. Emergency planning is critical to the facility in that everybody knows exactly what to do in a case of a fire. As part of the required HFS training, each caregiver is expected to demonstrate knowledge in the plan that has been established. In order to have an emergency plan, it must be coordinated with the local fire department and also in cooperation with DHFS, and it must be approved. The plan must have the following. It must include procedures for orderly evacuation and response during any emergency situation. It must identify the responsibilities of the staff. You have to know what is expected of you in an emergency and in order to follow that. You need to identify those actions of the residents. Again, in the assessment, it's critical that you find out what those residents are going to do in a time of emergency. You're responsible for them. You need to know what is expected. You need to identify any resources that you would have in an emergency. How do you know who is going to be there when the fire occurs? How many people does it take to get those residents out? Where are you going to go once you get outside? If it's cold outside, how do you get those people to a warm place? It needs to be approved by the DHFS. The DHFS wants to make sure that you follow the proper procedures. They want to make sure that you're following proper state guides and that you're following proper fire department guidelines as well. It should be coordinated with the local fire department and other responding agencies, remembering that it's important that you work with the fire department. Some fire departments don't know exactly what community facilities are in their cities. It must be posted in a conspicuous place and readily available to their staff and your residents. Again, those people need to know exactly what is expected of them. Having it in hallways on multiple floors, having it posted on the resident's door, they need to understand primary, secondary exits. The main goal of the emergency plan would be life safety and property conservation. Remembering the most critical thing is that everybody gets out of that facility alive. It's important to have an attached diagram on your emergency plan. The attached diagram would be located on floors, again, accessible to staff and residents so that they have an idea of what is primary exits and what are secondary exits. Also want to identify in that particular plan any hazardous areas or problem areas. Remembering that day-to-day process, you need to keep the hallways, the exits, all of those areas free and accessible in an emergency situation. You need to identify any of your safety procedures that may be taken. You want to identify the person that is in charge of your emergency planning, your facility owner. Anytime you have any comments regarding the plan or evaluations, you need to go to that person so modifications can be made. You want to make sure you understand what the emergency contacts are. If you have a situation, remembering you must contact certain people and let them know. Not just the fire department needs to be notified, DHFS needs to be notified as well. You need to identify the responsibilities of any visitors and volunteers, remembering that each day different people are coming throughout your facility. There may be occasions where you have more or less people than what you anticipated. It must be written so that all of the people understand it, not only the staff, but the residents as well. Remembering residents can help to help themselves in a fire situation. And you need to comprehend it. You need to know what each part of that is and what is expected of you in an emergency situation. You need to review that on a regular basis. You also need to modify it as needed. Practicing is critical with emergency plans. The more you practice, the better you will be in an emergency. You need to provide that emergency plan for any type of emergency that you have. Although the power outages, tornadoes, floodings are all critical, most of what we cover today is regards to fire safety. It's important that emergency plans are practiced. All the emergency plans in the world aren't going to do you any good if you don't know what is expected of you when you have an emergency. It's also critical that the fire department is involved in your planning process and that DHFS is notified and is a part of that process as well. It's important because all of us working together are going to help in your emergency planning to make the best plan for your facility. In a time of emergency, help is what you need, and help is what you need to identify on your plan. In closing in this, I would like to emphasize the fact that it's important to assess the facility on a day-to-day basis. Most of you starting with the facility are going to be working in a situation where the plan is already established. All you need to do is find the plan, review it, and make any comments or suggestions as you go throughout the day. Remembering a fire could hit at any moment or any time of your working shift, so you have to know what is expected regardless of the time of day that it occurs. Follow your emergency plan, know your emergency plan, understand it, and use it when you have an emergency. An important part of the emergency plan is specified for certain types of residents. Again, when assessing the residents for life safety ability, it's important that the CBRF emergency plan includes those residents who, one, are capable but who refuse to follow the prescribed emergency plan guidelines, or the ability to comprehend or follow through simple instructions. Those who have impaired mobility or consciousness would have a difficult time, and the emergency plan should have procedures for those people. Or those people that have absolutely no desire for self-preservation. Elderly people sometimes look at emergencies and want to stay where they are regardless of the situation. Some of those alternative procedures will be described for those particular residents. Having residents stay in their room with the door closed, awaiting for the fire department to arrive, may be your only option. Staff should be informed within 24 hours of any resident whom alternate emergency plans exist and what alternate plans may be for that particular resident. When there are alternate emergency plans for residents, there will be quarterly evaluations of that resident's ability to promptly evacuate the CBRF. Alternate emergency planning procedures will be updated each quarter, including any changes that have been made to the particular plan. Staff shall be made aware of any changes in the resident's alternate emergency plan. All of these are critical to work with your staff and advise the DHFS for approval in the plan. Again, it's important to know what residents you have and their abilities when evacuating. In this next section, we're going to talk about fire prevention. Fire prevention is a very important part of reducing the chance that you'd have a fire in your facility in the first place. The National Fire Protection Association has kept a number of statistics over the years on fire fatalities. Of course, fire fatalities most occur in the residence, and they occur between the hours of 12 midnight and 6 a.m. Most people die in fatal fires because of smoke inhalation. It's generally the smoke that travels throughout the building, trapping people and limiting their breathing. More fire deaths occur in a facility in the living room areas, such as the recreation rooms, TV areas, where people congregate. CBRFs that allow smoking are more likely to have fatal fires than other facilities that do not allow smoking to occur. In a facility that does have smoking, there are a number of requirements that you should take note. First of all, remember that smoking is the #1 cause of fire-related deaths in the residential setting. With that in mind, every CBRF must have a written policy on smoking and the use of smoking materials. The policy must designate where smoking is going to be permitted, if any. The policy shall also clearly communicate to new residents upon their admission what that policy would require. And the policy shall clearly communicate to the new staff upon beginning of employment. Designated smoking areas shall be well vented, and alternate means of eliminating the smoke shall be provided. Any designated smoking area shall certainly comply with the Clean Indoor Act provision in the Wisconsin state statute. Another type of hazard that you'd find that's very common in the residential facility is electrical type hazards. Electrical systems are a common cause of fires. Fire department on many occasions have gone out to homes where wiring has been affected. Wiring not up to code can be a contributing factor in electrical fires. Extension cords should be used as temporary wiring, but should never be used for servicing large appliances. It's important to note that extension cords should be rated for the ampere capacity of that particular appliance. If you take a look at an example I brought along, I have an extension cord that's very common extension cord you'd find in a hardware store. The extension cord comes in various lengths, but what I'd like you to note is the size of the extension cord. I'll take another type of a cord. In this particular case, this extension cord, both designed to do the same types of things. This one is on a circuit breaker. This one is not. In a situation where you have a cord plugged into an outlet, certainly the weakest link in the electrical wiring is going to start melting and get hot. In this particular case, which cord do you think would create a fire if you had one in your home? Would it be the small one or this large one with a circuit breaker? Anytime the fire code requires an extension cord, it's always temporarily supposed to be used. Extension cords, even on the smallest wires, when you're talking about Christmas decorations and things like that, should be rated and at minimum UL approved. Wherever possible, you want to try to put appliances near the outlet, remembering that outlets are only rated for the number of plugs that they have in them. If it has 2 plugs, then you should only have 2 items plugged into that. If you're going to go any more than that, then a proper rated cord, or you may need permanent wiring to get to that location. Residents should always be supervised when using cooking equipment or where food is being prepared. In addition, staff need to be very careful about what they leave out in plain view of residents and in areas where residents have dementia problems and things of that sort. You want to be careful of any types of equipment that may be inadvertently turned on. Some of the other issues that we need to look at in electrical hazards is fire extinguishers. When working, it should be very close to food as it's being prepared. It's not uncommon where a stove will have a fire and an extinguisher would be needed in a short amount of time. Ventilation systems should be maintained and cleaned according to the manufacturer's guidelines. Residents should be assessed for their ability to prevent fires and be fire safe. Electrical hazards are something that code enforcement and state codes and also your building codes and wiring codes would handle most of the types of things in your home. However, it would be up to you to make sure that extension cords and appliances that weren't working properly were noted and taken out of service. The next section we'll talk about is heating systems. Now, in most cases, heating systems are not something that the average worker is going to be able to maintain. However, you need to have some understanding of what things to look for as far as any fire hazards are concerned. The use of any open flame in a CBRF could be a primary ignition source for any types of combustible materials that were stored nearby. You need to state very specific on a regulating space type of auxiliary heaters. You can't use auxiliary heaters in many cases where combustibles are fairly close. And in many cases, the code requires a minimum of 36 inches from any type of auxiliary heating device. Extreme caution should be used when using any space type heater next to residents or elderly people as well. Another important point to make about prevention is understanding what the habits are of the people that are using the facility. Major human elements and cause of CBRFs might be carelessness, somebody that you have there that's smoking in bed. Sometimes you're aware of it, sometimes you may not be aware of it. Any type of an ignorance type situation, for instance, using that extension cord for permanent wiring would be a hazard that you wouldn't want to do. Negligence might be a human element to cause a fire, forgetting to turn off a stove or a burner, or walking away from the stove and allowing a resident to come up and touch it or spill something. Or incendiary type fires. Incendiary aren't as common, but it's an employee rage or employee revenge, something to get back at the facility could cause a fire or intentionally set fire. Remember that CBRFs should always maintain clear paths to all exits. All exit doors should be operable at all times. Exits should never be locked from the inside. Alarms that can be used for exits are fine, but it's critical that these exits aren't blocked or locked. Any fire detection or suppression system that you have in the facility must be working in order to protect you when you're sleeping. They must be inspected on a regular basis. You need a good prevention program as part of your smoke detection system. Smoke alarms, heat detectors, and sprinkler systems all need to be working properly. When you're working with fire prevention, it's important that all these things are covered. The DHFS has a handout. It's a fire inspection handout that's part of the program. It's important that all CBRFs do have an inspection on an annual basis. Fire inspection means a way of fire prevention. It also assists the CBRF in not only maintaining a safe and orderly facility, but is one that is compliant with state or local codes. The fire inspection form assists the owner in evaluating that CBRF. Things like general housekeeping conditions. Are they in order? Is things put where they're supposed to be? Or are things where they're not supposed to be and prohibit the evacuation of residents? Are combustibles stored too close to ignition sources? You'd have to identify the ignition sources and eliminate those or move those combustibles so they wouldn't catch on fire. Are flammables stored in their proper places? Or are they in cans that are not properly vented? Or are they near a heat source? If an appliance is not plugged in directly to an outlet, is there an extension cord that's there? Or are the cords frayed and not good working order? If you are having smoking areas, are those areas properly designated? Do people know where they're supposed to go and smoke? Are they properly monitored by the staff? Do you go around and check, making sure that the ashtrays are emptied, making sure that there are no papers and things like that that are possibly going to catch on fire? If the disposing of ashtrays are properly in ash cans, metal cans are appropriate for those types of things. Dumping an ashtray in the garbage or a waste paper basket with other combustibles could start a fire. If you have dryers in your facility, dryers are a common cause of fires. Dryers can cause fires because they're not clean, lint traps aren't cleaned out, or they're not properly vented, or not properly vented with the proper materials? Are they in good working order? Do you maintain the dryer? Do you keep the clothes in under the manufacturer's guidelines and follow the rules or the orders of the facility? The safety of the workshop or areas or tools that you might have in your facility is an area that needs to be concentrated on. Many types of things are done in a workshop, heating, plumbing type things, electrical type things with appliances that are possibly a cause of ignition for a fire. Need to maintain those areas and make sure that those are kept nice and clean. If you take a look at your facility, always watch and look for the exits and making sure that the exit lights are illuminated if you have them, making sure that doors are properly working, making sure that the passageways are clean and free for evacuation if needed. The inspection of the facility also covers the dates and the operation or the condition of fire detection and suppression systems. If it's a multi-story building, that may spread fire to other areas or other residential units as well. It's critical that those areas are all checked on a timely basis. The safety of any air conditioning systems is important to keep maintained and make sure that people, not only while the things are running, somebody can hear the smoke detection system if it actually goes off at night. The safety of any storage buildings or attached buildings, any ventilation storage of flammable liquids and products, such as in your garage. You park vehicles in garages, or you have flammables or lawnmowers and things of that sort. All those things should be properly stored according to code and the DHFS guidelines. A fire inspection report upon completion should be kept on file with your facility, also on file with the local fire department. The fire department will use that inspection report when they come back for the next one to make sure that your corrections have been made. The DHFS also keeps a copy on file for your licensing agreements. The fire inspection really is a checklist for you to go through your facility and make sure that all of the things that you may have forgotten about are covered and that you have prevented or potentially prevented a fire from starting in the first place. If you have a fire inspection report, use it. You do it on an annual basis, coordinate it with the fire department, and it'll help you in preventing a fire. That concludes the material that we've talked about in all the different units. And now at this time, I'd like you to take a post-test, which is the same test you took as the pre-test when we started the units out. Take the post-test, and we'll come back after this to review your answers. Welcome back. Let's go over the answers to the post-test. Number 1, from the onset of fire, how long could it take before a room becomes fully engulfed in smoke and fire? The answer is B, 2 to 5 minutes. Number 2, what 3 things must be present for a fire to start? The answer is C, heat, fuel, and air. Number 3, what are the 4 classes of fire? The answer is C, combustibles, flammable liquids, gases, electrical, and metals. Number 4, what is the most common cause of fatal fires in a CBRF? The answer is A, careless use of matches, lighters, etc. Number 5, the most common type of fire extinguishers used in a CBRF are, the answer is C, multi-purpose dry chemical. Number 6, what type of detector is the most commonly found in kitchen area of a CBRF? The answer is A, it's a heat detector. Number 7, the maximum time limit for evacuation of residents in a licensed CBRF without a sprinkler system would be, the answer is C, 2 minutes. Number 8, type of evacuation drill that is most helpful in determining the actual time it takes for an external evacuation would be C, a surprise drill. Number 9, in the event of a fire, 4 important actions would be prioritized correctly in which of the following lists? The answer is C, rescue those in immediate danger, activate the alarm and contact the fire department, contain the fire, and extinguish the fire or evacuate. Number 10, of the following statements, which is the most correct when discussing the use of extension cords in a CBRF? The answer is C. When extension cords are required, they shall be rated appropriately for the ampere capacity of the appliance being used. Now that we've completed the material in this videotape, I want to end on a couple notes. First of all, we hope that you've reduced any type of anxiety that you've had about fires. I hope that I've helped you to realize what fire is all about and the potential threat that fire has to you and your facility. I hope that you understand that the type of damage that fire can cause and the threat to you and the people that are living in your facility are. I hope that you'll take a very proactive approach with fire prevention to help reduce the chance that a fire occurs in the first place. That you understand why it is so important that we continually assess you, your residents, and your ability to evacuate the facility in a timely manner. I hope that you practice the RACE and make sure that you know what to do when a fire does in fact occur. I sincerely hope that you never have a fire in your facility, but if you do, above all, the most important thing is that you get out alive. Thank you.